Hello everybody, welcome into another lesson. Today we are going to talk more about sequences, and particularly arithmetic sequences. And let me write that out for you, what that's called. Arithmetic sequence. So there are different types of sequences, but today we're going to stick to the easiest type called an arithmetic sequence. That's where you have the same common difference between each number, as opposed to other types of sequences where there could be different differences between each number. So let's start here with our first sequence. You have the sequence of 16, then 17, then 18, then 19, and it just keeps going. They want you to find the 23rd term of the sequence. So they don't want the 5th term or the 6th or so on. They want the 23rd term in particular. There's two ways we can do this. The first way is to sit down, since you have the first 4 terms, write out 19 more terms till you arrive at your 23rd term. I don't think anybody's about that life. I'm certainly not. And I doubt any of you are either. There is a shortcut, however, which is what I'm going to show you. That's the second method, is the shortcut. So, whenever you are faced with a sequence, you want to, arithmetic means they have the same difference. So you want to figure out what the difference is between each number. To get from 16 to 17, you add 1. To get from 17 to 18, you add 1. To get from 18 to 19, you add 1. So it looks to be that the common difference, so let's see here, the common difference equals 1. So we figured out our common difference. Common difference is 1. What you'll want to do now is you'll want to figure out what the term is. So you'll say t for the term itself is equal to, we'll say the common difference, which I'll just call d, times n, which would be the number of the term you're on. In this case, the term is equal to, what's the common difference? It's 1 times n, which would be the number of the term you're on. So furthermore, t, since would equal, since we have 1n, it would just be n. Okay. Now, if we stick in, let's say we have n, which would be the first term. So let's say we have the first term, right? We stick in 1 for n. It would look like you get 1 for your first term. But to get from 1 to 16, because your first term is really 16, right? What you're going to do, you figure out how much of a difference is it from 1 to 16. It's 15 more. So you would add 15. Thus giving you your first term is 16. So to find your term, it's going to be that common difference times n, which is 1 times n, or just simply n, plus 15. Okay? Let's say we stick in, to get your term, let's say we stick in the second term, which is listed, plus 15, because n, it represents the number of term you're on. The second term plus 15, which would equal 17. We do in fact get 17 for our second term, so we know that n plus 15 is a sound, it's a very sound piece to use to figure out what subsequent terms are. So they want to know the 23rd term. While t would be the term itself, n, the 23rd term, you would put in 23 for n, then just plus 15. Well, the term is equal to 23 plus 15, which is 38. So the 23rd term of this arithmetic sequence is going to be 38. Much easier than sitting down trying to figure out, write down 19 terms to get to where we need to go. All right, what's the next one? Okay, so we have 14, 15, 16, 17, and it just keeps on going. What term do they want you to find? The 16th term. So for this one, we will find the 16th term. All right, so we have 4 terms listed, 14, 15, 16, 17. They want you to find the 16th term. Well, I don't think you feel like sitting down writing out 12 more terms, so we're going to use a shortcut we've learned. First, again, figure out the common difference between each of the terms of this sequence. To get from 14 to 15, you simply add 1. To get from 15 to 16, you simply add 1. To get from 16 to 17, you simply add 1. Okay. So it looks like the common difference, once again, is 1. Common difference equals 1. So, to figure out your term, you're going to take that common difference of 1 times the number of term you're on. Which would, since we have the common difference of 1 times the number n, that would just equal n. Okay? Now, once again, let's say we stick in the first term, right? To get the term itself. We just stick in 1 for the first term, you're only going to get 1. So, let me write that down here. Let's say we're doing the first term. It looks like you're going to get 1. Well, we need to get from 1 to 14. How do you get from 1 to 14? You got to add 13. So, and of course, 1 plus 13 equals 14. So, it looks to be that to get the term you're looking for, it's going to be n plus 13. In this case, it's going to be the common difference of 1 times the number of the term you're on plus 13. Now we can go for finding the 16th term. The term equals the number of the term you're on, which is 16, plus 13. So the term is equal 16 plus 13, which is 29. So the 16th term of the sequence is going to be 29. And I got even more. Alright, we have 4, 8, 12, 16, and then it just keeps on going. What term do they want us to find? The 13th term. Find the 13th term. Okay, so once again, we're being asked to find the 13th term of the sequence of 4, 8, 12, and 16. First thing, figure out your common difference. Between 4 and 8, you add 4. Between 8 and 12, you add 4. Between 12 and 16, well, you're going to add 4. So, it looks to be that you have a common difference of 4. So the term is going to equal that common difference of 4 times the number of term you're on. Well, that's only part of it. We need to see if we need to add any additional factors here, add any additional to this equation. What you would do, figure out your first term. So you'll take the term, you'll do 4 times your first term, which is 1. That'd be 1 for n. And it looks like you just get 4. So you don't need to add or subtract anything to get your first term. So literally, to get what term it is, you'll just do 4n. There's nothing additional to subtract or add. So at this point, they want you to find a 13th term. So the term itself is equal to 4 times the number of the term you're seeking. For n, it would be times 13. So it looks like the 13th term, 4 times 13, that'd be 52. So the answer to this would be 52 for your 13th term. All right. We have 11, 22, 33, and 44. Then it just keeps on going. They want you to find the 25th term. Find the 25th term. Well, so we have another arithmetic sequence of 11, 22, 33, and 44. They want you to find the 25th term. I don't think you want to sit there and write out 21 more terms. I certainly don't. So, first thing you're going to do, figure out the common difference between each term. Between 11 and 22, it's going to be plus 11. Between 22 and 33, that's another plus 11. Between 33 and 44, that's another plus 11. So it's safe to say that your common difference, so the common difference in this case equals 11. Alright, so the term you seek is going to be that common difference of 11 times the number of term you're on. 11 times the number of term you're on. Now what we're going to do is stick in the first term here. You'll have 11 times the first term, which is 1. Well, the term itself for the first term is equal to 11. To get from 11 to 11, you don't add or subtract anything. So literally, the formula to find terms for this sequence is just going to be 11 times the number of the term you're on. Okay? So now you're going to find, of course, the 25th term. You'll just take 11 and put in 25 for n. Well, the term is going to equal 11 times 25. That would be 275. So the 25th term of this sequence is going to be 275. See how much better knowing how to make the shortcut formula works for you instead of trying to sit down and write out a bunch of terms? Because what if they were asking for the 70th term or the 100th term? I don't think you want to sit there and write all that. Okay, we have 7, 10, 13, and 16. And it just keeps going. And what term do they want you to find? The 20th term. Find the 20th term, okay? So you got an arithmetic sequence here. So you have 7, 10, 13, and 16. They want you to find the 20th term. First things first, figure out what the common difference between each term is. So between 7 and 10, it's plus 3. Between 10 and 13, it's another plus 3. Between 13 and 16, that's yet another plus 3. Okay. So what you're going to do now, you write down what your common difference is. Your common difference equals 3. So the term so far is going to be that common difference of 3 times the number of the term you're on. So let's stick in the first term. To get the term of the first term, it's going to be 3 times, we'll put 1 in for n since that's the number of the term we're on. So the answer to that would be 3. Well, how do you get from 3 to 7 for your first term? You got to add 4. So really, the term that you're seeking is going to be 3 times n plus 4. Because to get from 3 to 7, you got to add 4. Now, so the term is going to be the common difference of 3 times the number of term you're on plus 4. That is what you're going to get for finding out what your term is. So we want to find the 20th term. So the term itself will be equal to 3 times the number of the term you're on. In this case, it would be 20. So 3 times 20 plus 4. Which is going to equal 3 times 20 is 60 plus 4. So the 20th term, it looks like, would be 64. That would be your answer for the 20th term, would be 64. All right. I got 3 more. We got 7, 9, 11, and 13. And it just keeps going. They want you to find the 33rd term. So you got to find the 33rd term of this sequence. Okay. Of course, like you would first, you're going to start out figuring out your common difference. So from 7 to 9, that's plus 2. From 9 to 11, that's another plus 2. From 11 to 13, that's another plus 2. So it's safe to say that your common difference is going to be 2. So the common difference equals 2. Alright? So now to get the term itself, you're going to take that common difference, which in this case is 2, times the number of term you're on. Alright? Well, let's figure out your first term here. The term is equal to 2 times the first term, the number of the term, which in this case is 1, which of course would equal 2. Well, we know the first term is actually 7, so how do we get from 2 to 7? You got to add 5. So each term is going to be equal to that common difference of 2 times the number of term you're on plus 5. Because to get from 2 to 7, you got to add 5. So therefore, the term itself is equal to the common difference of 2 times the number of term you're on plus 5. Now they want you to find the 33rd term. So the term is going to be equal to 2 times the number of the term you're looking for, which would be 33 plus 5. Which we know 2 times 33 is 66. Then we have that plus 5. So the term, the 33rd term, is 66 plus 5. That would be 71. Beats sitting down and writing out 29 more terms, doesn't it? You can just figure out that it's 71 based on these shortcut formulas we got here. Alright, so 33rd term is 71. I got 2 more. Alright. We got 1, 5, 9, and 13. 1, 5, 9, and 13, but wow. They want you to find the 89th term. Find the 89th term of this sequence. Well, we certainly are not about to sit down and write out 85 more terms. That just isn't going to fly. What you got to do, again, figure out what your common difference is between these numbers. Between 1 and 5, you add 4. Between 5 and 9, you're going to add yet another 4. Between 9 and 13, you're going to add yet another 4. So we can establish that the common difference is 4. So the common difference equals 4. Okay? So to get the term, you're going to do that common difference of 4 times the number of the term you're on. So, let's stick in again to get the term. Let's stick in our first term, 4 times 1, for the number of the term. You would get 4. Well, we know the first term is actually 1. How are we going to get from 4 to 1? You got to subtract 3. So the term is going to be equal to, of course, that common difference of 4 times the number of term you're on. But to get from 4 to 1, you subtract 3. So to figure out what term it is, you're going to actually do the common difference of 4 times that number of the term you're on minus 3. Now we can go and find the 89th term. So the term is going to be equal to 4 times the term 89 minus 3. Okay. Let's figure out what the heck is 4 times 89. 4 times 89 is 356. So it's going to be 356 minus 3, which we know would be 353. So the 89th term of this sequence is going to be 353. Yowzer, I don't think anybody wants to sit down and write out that many terms. It's just good to know how to create a shortcut. So the 89th term is 353. Alright, last one. We have 3, 8, 13, and 18. And it keeps going. They want you to find the 70th term. So that's still pretty high up there. They want you to find the 70th term. I don't think you want to write out 66 more terms to figure it out. So what you're going to do first, find the common difference between these numbers. Between 3 and 8, you're adding 5. Between 8 and 13, you're adding yet another 5. Between 13 and 18, you're adding yet another 5. So it's safe to say that our common difference is 5. Oh yeah, the common difference is equal to 5. Okay? Now, of course, to figure out the term, you're going to take that common difference of 5 times the number of term you're on. Because the term always starts with the common difference times the number of term you're on. So let's go ahead, let's stick in the first term. 5 times your n for your first term would be 1. So the term would happen to equal 5. Well, the first term is not 5, it's actually 3. How do we get from 5 to 3? You gotta subtract 2. So to figure out the term, it's still the common difference of 5 times the number of term you're on. Then you're gonna have to subtract 2. So what you gotta do then is the term, then you always the common difference times the number of the term you're on. In this case, the common difference is 5 times the number of the term n. Then you have all that minus 2. Now we can proceed to find the 70th term. So the term would be equal to 5 times the number of the term, which is 70, minus 2, which we know 5 times 70 is going to be, well, 350, then minus 2. So the 70th term happens to be 348. So the answer to this would be 348. So when doing these arithmetic sequences, what you always want to do, no matter what term they ask you to find, you start out with figuring out what is your common difference between each of the terms. Alright, so then what you'll do is for the term, it'll be that common difference times the number of term you're on. It starts with that. It doesn't end with that. It starts with that. And then what you need to do is figure out your first term. So you stick in 1 for n for your first term. You'll get some value. And then you need to see how it lines up with what your actual first term is. Had my actual first term been 5, I wouldn't have had to add or subtract anything. It just would have been 5n. But to get, in this case, from 5 to 3, I had to subtract an additional 2. So to figure out whatever term it was, it's going to be that common difference times the number of term, which in this case was 5 for the common difference times the number of the term minus 2. And then once you've established your equation, you just stick in the number of the term you're seeking in for the n value, and you'll get your term. So that's really all there is to these. We won't cover other sequences till probably Algebra 2. So you can rest easy that this is all we're going to see for now. But the next lesson, we're going to be using formulas such as the distance formula, d equals rt, and then we'll be finding areas of rectangles and squares. And then we'll actually figure out missing values using those formulas. We'll do a little bit of algebra with them. So I hope everybody has a good night. Take care.